achieve real-time medicine. AI is ushering in a new era. It's a very dynamic era where we can monitor patients and provide real-time, as you said, diagnoses, treatments, and monitor treatment plans, and even predict things like we never before, predict things before they happen. So that's really super, I think, enticing, exciting part of all of this. How is real-time medicine going to actually evolve?
It's also real-time change, because the idea is that if I can leverage data to make a decision about a medicine or a therapeutic route, it's more immediate, as opposed to waiting for the specialist, then the follow-up appointment, and the 6 weeks and 8 weeks, and next thing you know, the diagnosis to treatment window has now been truncated, so it's ongoing. I mean, you know, banks have better hours and availability for questions and answers than we do in healthcare, which is scary. So, and we used to say you had bankers' hours. Well, now you have healthcare hours sometimes because the availability of some of these providers, although we're supposed to be available 24/7, the ability to actually make interventions and changes isn't 24/7. So this is what I really get excited about.
People's health is 24/7.
Exactly right.
Yeah.
Going back, you know, to the sort of the concept of real time. AI algorithms are continuously vigilant. They don't get bored and they don't get distracted. And if you think
They're
about
not biased.
and they're not biased. If you think about the mechanisms that avoid car crashes that are in everybody's car, they sample 50 times a second roughly, and they integrate multiple data feeds. And they're always on. They don't get distracted. And you think about heart failure, and what you see there is it's kind of a slow progression to a heart failure exacerbation. There's small changes in the central venous pressure and small changes in the myocardial pumping characteristics and probably small changes in the activity. But to the person or the person observing them, they look about the same because it's over the course of 2 weeks. But if you have that hyper-vigilant algorithm and it's equipped with the right measurement information, not chasing symptoms, but actually the hemodynamic parameters that lead to edema or myocardial dysfunction, the opportunities to have incredible improvements are there. It's hard to do, you know, hard measurements to make, hard technology to get adopted, but I just keep thinking, wow, I would like to have an algorithm that doesn't get bored and doesn't get distracted, sitting on my shoulder watching over me as I get older.
24/7.
24/7.
I'll get back to that patient example I gave you, that common patient that fell down and was injured, maybe badly injured. And that was all, the root of all of that, if you go back, was a blood pressure issue. Maybe he had high blood pressure, maybe his primary care doctor prescribed a medicine, maybe he wasn't really taking it diligently. We didn't know that, of course. We could know that with real-time medicine. So the primary care doctor who checks that patient episodically may say maybe a week later, blood pressure is still elevated, inclined to maybe we change the dose, make it higher, maybe it happens again. Then then say the patient gets serious, well, I'm going to really start taking these medicines. And then they start taking all of them, and they become hypotensive. So that whole scenario, we could monitor all of that and prevent all of it. And it's very, very feasible. And so I think about this real-time medicine, back to that example, and that's just one of multiple different examples where, you know, something happened and it kept building up until, like in the example of heart failure, you tipped over the edge of a Starling curve, and then everything goes, you know, awry. But we could know all of this much earlier.
Yeah. And then the goal is really to decrease your business in the ER, right? Because then patients aren't going there because they have the peace of mind.
Yeah.
You know, they're actually the condition is stable. Because when I talk about the medical behavioral, you know, integration, you know, we have to be conscious that there's a lot of unknown about, you know, am I getting worse? Do I feel worse? I'm a little short of breath. Is it real shortness of breath? So you point about symptom versus true disease, and allowing that information to be brought to the patient and say, yes, you need care. no, you can wait till tomorrow, or, you know, you're fine, is so powerful in the way we think about the delivery of care, specifically the way the mind kind of generates a lot of our decision making, whether it's needed or not needed, you know, based on the way we escalate services.
Yeah, and we talked before about, you know, reactive care. We're basing everything on symptoms, you know, and the progression of symptoms. And symptoms progress and progress until they get to a certain threshold, and then, you know, the alarm goes off, and people are going to go to the emergency room or whatever they need to do at that time. But we could be monitoring all of that stuff way before people have symptoms.
If you go back a little bit to your fall example, and that's an area actually I work in, which is to say, oftentimes those medications, they decrease the sodium concentration in the blood. So they decrease the drive to drink, because elevated sodium concentration is the mechanism by which you get thirsty. So now you have an older person that is not drinking as much as they should because you've inhibited that mechanism. And then there are a number of hypertensive medications and heart failure medications that delay the autonomic response, what has to happen so you don't faint when you stand up. So now you have a situation where you're prescribing something, family practice, ER, cardiology, they're not coordinated, and you can have this cascade of medications that takes the patient's fall risk way up. So you look at that and you say, okay, is there the ability to have AI examine that? And then you move actually exactly to the monitoring of it. And the process of looking at how your body responds as you move from a laying down position to a standing position tells you exactly what the hydration status or the effective circulating volume is. And as that begins to dissipate and you see a slower response, you automatically know the person's a setup for a fall. And you can do it incredibly well with nothing more complicated than a Fitbit.
Yeah, it's wild.
Right. You know, we talk about blood pressure, we've talked about diabetes, you know, heart failure. There's a whole slew of different disease entities that we can monitor people and help prevent these things.